So welcome back to the new episode, still on the application of the compound angles. So our example 2 goes, example 2, if sin A equals 4 out of 5 and cos B equals 12 out of 13, where A is obtuse and B is acute, find the values of Roman 1, sin into A minus B, Roman 2, tan into A minus B, Roman 3, tan into A plus B. Now, when we talk about obtuse angles, what comes into your mind? Obtuse angles are angles ranging from 90 degrees to 180 degrees. What about acute? Acute angles are angles ranging from 0 or below 90 degrees, ranging from 0 to 90 degrees or below, but below that one. That's what I call them. So when you try to illustrate, you can even first sketch ours. And start with, from here, this is 0, this is 90, this is 180. So this one here, from there to here, we are calling it angle A because it's an acute. So those are the one called acute. So from there, can try to redraw a triangle. Sine is given as what? Opposite over hypotenuse. Is given as, from the word SOHCAHTOA, can have our mindset of SOHCAHTOA. Sine is given as what? Opposite of hypotenuse. When I'm here, this is my opposite. My opposite is given as 4, and this is my hypotenuse. From Pythagoras theorem, this one can call it x. From Pythagoras theorem, we are going to have x squared plus 4 squared equals 5 squared. We have got x squared plus 16 equals 25. So x squared equals 9, x alone equals 3. See, but always we follow the Cartesian plane. The angles, the sides from here to here are taken as negative. So x here is 3. Then also go to the one of acute. You also locate first. This is angle B. So what is acute? It is given as 12 over 13, and cosine is adjacent of hypotenuse. This is our adjacent, and the hypotenuse is already 13. I don't know this one, I can call it y. Still from Pythagoras theorem, I'm going to say 12 squared plus y squared equals 13 squared. This is 144 plus y squared equals 169. We take it there. So y squared becomes 25. So what is y? Y equals, do you know the square root of 25? The square root of 25 is already 5. So after knowing that the square root of 25 is already 5, we go ahead and we find. And even you can go ahead and do the subtraction of it. 169 minus 144. We are getting 25, and the square root is already 5. Then from there, go ahead and now find these values of here. What will be sin A? Can you get sin A? We have already got as sin A is already 4 out of 5. What about cos of A? Cosine is given as adjacent of hypotenuse. The adjacent is already 3, but is a negative 3 out of 5, because this side on the Cartesian is a negative. We also get a tan of A. Tan is given as what? Opposite of adjacent, which is 4 out of 3, which affects it and becomes negative 4. So also from here, we need also to get sine of B, because we are given only cos B. Can we get sine B? What will be sine B? Let me write it here. What will be sine B? Sine is given as opposite over hypotenuse, where our opposite is already 5 out of 13. it becomes 5 out of 13. We also look at tan of B. Tan of B is given as what? Opposite of adjacent, which is 5 out of 12. So can we start with now our question which was given? The first one was sine into A minus B. So these are compound angles. The first step is first open them, as we say. Don't just substituting that A you know and B because you don't know them. So can we open? This is the same as sine A cos B minus cos A sine B. So do we know sine of A? Sine of A is given as 4 out of 5. This is 4 out of 5 times. Do we know cos of B? Cos of B is already 12 out of 13. 12 out of 13 minus. Do we know cos of A? Do we know cos of A? Cos of A is given as negative 3 out of 5. Negative 3 out of 5 times. Do we know sine of B? Sine of B is given as, sine of B is 5 out of 13. 5 out of 13. So, can we go ahead and we multiply? We start. 4 times 12, as I will be pressing on this calculator. 4 times 12, 4 times 12, we are coming up with 48. Up it is 48. Out of 5 times 13, you say 5 times 13, which is bringing us a 65. Then, minus into negative 3 times 5, you are getting negative 15 out of 65. So this becomes 48 out of 65. And negative minus minus becomes plus 15 out of 65. So when we add, since numbers have the same base, we just add their numerators because the denominators are the same. We say 48 plus 15, we are coming out with 63 out of 65. So it becomes 63 out of 65. You have already scored that one. That's how we do. After locating them, then you will be knowing how each is flowing. Then we are moving to another scenario, Roman 2. We are going to Roman 2. Tan into A minus B. These are tangents, but being compound. Roman 2 is saying tan into A minus B. So with tan, we have already seen its expression. You open it. This is the same as tan A minus tan B all over 1 plus tan A tan B. So what is the tan of A? Tan of A is already given to you as tan of A is negative 4 out of 3. Negative 4 out of 3 minus tan of B is already 5 out of 12 all over 1 plus tan of A is negative 4 out of 3, tan B 5 out of 12. So can we go ahead? So this is the same as negative 4 out of 3 minus 5 out of 12 all over 1 plus negative 4. You can reduce a 4 goes there. How many times? 3. So I remain with, well, let me first multiply it like this. Is negative 15 out of this times this, we are getting 36 to ease the work. So can we get the LCM up? The LCM up is already 12. 12 divided by 3, we are getting a 4. A 4 times negative 4, we are getting negative 16. 12 divided by 12, we are getting 1 times that, 5. So we are also again dividing by, what is the LCM here? 36. 36 divided by 1, we are getting 36 times 1, 36. Plus negative 15, which becomes negative 31, negative 16 minus 5, we are getting negative 21 out of 12. We say divided by 36 minus 15, we are coming out with 21 out of 36. We go ahead and we take the reciprocal. This becomes negative 21 out of 12 times 36 out of 21. By 21, 21 goes. How many times does 12 go in 36? 3 times, which becomes negative 3. This is the way how we cross such a kind of a number, and you come out when it is very perfect on that. Again, we are proceeding to Roman 3. We want to go to Roman 3. How does Roman 3 state? Roman 3 is saying turn into A plus B. When we go to Roman 3, where we have got a tangent of plus A plus B, we have already proved this identity. Go ahead and say tan into A plus B is the same as tan A plus tan B all over 1 minus tan A tan B. But do we know tan of A? We see on our expressions. Tan of A is given as negative 4 out of 3. We substitute negative 4 out of 3 plus. Do we know tan of B is already 5 out of 12? All over 1 minus tan of A is negative 4 out of 3. Tan B is already 5 out of 12. So can we go ahead and we find the LCM where possible? The LCM up is already 12. 12 divided by 3, we are coming out with 4. 4 times the negative 4, we are getting negative 16 plus 12 divided by 12, it is 1 times the 5, it is already 5. We are now dividing into 1 minus negative 4 times that is negative 20 out of 36. Can we go ahead and we apply the ideas of mathematics? Negative 16 plus 5, you are going to come out with negative 11 out of 12 divided by, this is 1. A negative times a negative, automatically you come out with a positive 20 out of 36. Can we get the LCM inside there? Because this is like out of 1. So this becomes negative 11 out of 12 divided by, the LCM here is 36. 36 divided by 1, we are getting 36. Times 1 is 36 plus 36 divided by 36, you're going to come out with 1 times 20, which is already 20, which becomes negative 11 out of 12 times, we take the reciprocal, this is 36 out of 36 plus 20, we are getting 56. We reduce where possible. Can a 12 go in 36? How many times? Those are 3. Then in negative 11 times 3, you're getting negative 33 out of 56, which is the same as turn into A plus B. That's how we handle such a kind of a number when it comes to that. What is important for you to know is that if it is an acute, it ranges from where to where. If it is an obtuse, ranges from where to where. If it is an reflex angle, where does it lie from?